Let's look at an example that involves circles. In this case, we want the shaded yellow rectangular region here, but it has a hole bored through it, so we don't want to include that part of the area. So the strategy we want to keep in mind is that our area is essentially equaling a rectangle minus the circle. And the regular formula is length times width, and for a circle it's pi times the radius squared. So in this context, we need to watch out because we are given the diameter of the circle all the way across, but we would need the radius, and so radius would be half of the diameter. So we would take that, divide it by 2 to get 7.4 inches. And that's what would be useful in our calculation there. So you could do these in two separate stages. You could do kind of area of the rectangle, say area of the rect for short, and we could say that would be 19.8 times 52.6. So 19.8 times 52.6, I get 1041.48. This would be square inches in this case. And I could also take the area of the circle, which would be pi times 7.4 squared. So I have a pi button times 7.4, and then I have a squared button there. Squared equals 172. In this case it would round down to 0, so 172.0, or just 172. I'll show the 0.0 just to show how it rounded. And so our area, if we went back up here, it would equal that big rectangle's area, take away the hole. So we would have 1041.48 minus 172. And you get 869.48. 869.48 square inches. So that is what the total area, just the yellow shaded portion of the rectangle, would be equal to in square inches. Let's look at another one that's similar but a little bit trickier. In this case, we've got a semicircle bitten out of our rectangle. It's kind of like a bridge. And it doesn't directly give us what we wish we knew, but is there a way that we could figure out the radius? Call that radius. Well, kind of. What would the diameter be? What we do know is the whole way across this rectangle is 64.3, and we know that this much of it is 36 and this much of it is 10.3, so the diameter would be like taking the whole way across and then subtracting those edges along the rectangle we don't want to count. And that would leave us just with the distance across the circle, the semicircle. So we could take 64.3 minus 36 minus 10.3, we get 18. 18 inches is the diameter of that semicircle, or circle, which means, of course, the radius would be half that much, or radius would equal 9 inches. Now we have what we need to calculate the area of a semicircle. So, again, our strategy will be to take the full rectangle's area and subtract the area of the semicircle. So again, this is a length times width. But a semicircle, remember, is half of a full circle. So it's just like saying pi r squared, but we would divide it by 2 because it's a semicircle. For semicircle. So let's see what these numbers would look like here. So we could do this in one line if we wanted to. We could say length times width. For the big rectangle, it's an 11.8 by 64.3. And you know what, why don't we do it in pieces here? So this is area of the rectangle, we'll say. So we'd have 11.8 times 64.3. 758.74 square inches. The area of a semicircle would be pi times 9 squared, and then we'll divide that by 2. Now don't forget, squaring is not multiplying by 2. That means times itself. So that means 9, well, we could use our calculator here, do it all in one step if we wanted to, but 9 times 9 is 81. We could take pi times 9 squared and then divide that by 2 equals 127.23. 127.23 square inches. So now we've got the area of our semicircle. So our total area, put the pieces together here, we go with our big rectangle's area and we subtract half a circle. So we get 758.74 minus 127.23. And we could round that to one decimal place if we wanted to. 631.5. And this is measured in square inches because it's an area that we're talking about. So in this case, the trickiest part was actually getting the radius of that semicircle, because you had to take the whole way across, subtract the lengths you knew, which left you with the width across the circle, which you divided by 2 to get the radius. One more example here. What if we had bites taken out of all the corners? This is a quarter of a circle, but if you have 4 quarters, what do you get? You get a full circle. This is equivalent to saying a full rectangle. It's not quite a square. Notice the distances are different, but we could actually just figure out what these are worth and multiply, or just treat it like a full circle. So we could say this area is really saying the rectangle minus a circle, which is really the 4 quarters put together. So I'll just sort of draw it like that. So that's just pi times the radius squared. And this is length times width. So what we'll need is the radius. So let's see if we can figure that out. If we know this total length all the way across is the 35.5, and we know that this 17.7, in that case, if we subtracted the 17.7, it would leave us with this and this. So if we took 35.5 and subtracted the 17.7, that would leave us with actually 2 of the radius, which would kind of be the diameter. So we could even say diameter equals. And so then we would need to divide our answer by 2 to get the radius of the circle. So 35.5 minus that length across the middle, 17.8. So then the radius would be half that much. We could divide it by 2, get 8.9. 8.9 inches. So now we could calculate our area as the big rectangle, 34.8 minus 30, no, times, sorry, 35.5. Notice these little lines here. Those tell you that things are the same length. That's why I didn't need to calculate the radius again vertically, because it has the same congruent symbol, which means same length, in all of these quarter circles. So we would subtract pi times 8.9 squared. Let's do this in one line here. See if it'll do it. So 34.8 minus 35.5. Sorry, I will say minus here. It's multiplied by. Correction. Start over. 34.8 multiplied by 35.5 so equals, and then minus pi times 8.9 squared equals 986 point, it's a 5 but followed by another 5, which is halfway, so we're going to go up to 986.6 square inches. Inches squared. So that's our total area. So a trick in this one is that 4 quarter circles make a big circle. Now you could have done a rectangle minus a quarter circle minus a quarter circle minus the top corner circle minus the bottom quarter circle, and you would get the same answer. You just sort of do it in smaller pieces, but as a shortcut, 4 quarter circles make a circle. Alright, thanks for sticking with it. Hopefully this helps you with the 2 that you need to solve on your own.